Hi everybody. I want to teach you about something super cool called interval inversion. We can use this as a conceptual tool to help us determine the quality of big intervals. Let me show you how it works. How would we label this interval? E to F. You might recognize that as a half step or a minor second. Now let me show you what interval inversion does. If you take one of the notes and displace it by an octave, like this, we no longer have a second, but what is the number? It's a 7, and minor intervals invert to major ones. This is something you can memorize as a quick tool to get a large interval quality. Let me prove it to you though. If we take our F to E and we relate it to a major scale, indeed, F to E would be a major seventh. Why? Because E natural is scale degree 7 in the F major scale. Let me show you another example. Here we're going to start with a major second. In this case, G to A. Using interval inversion, we're going to take the lower note and put it an octave higher. The number inverts to a 7. You'll notice all seconds invert to sevenths and sevenths invert to seconds. And then the quality this time, however, is not going to be major, but instead minor. A to G is a minor seventh. Let me prove it to you. Here's our A major scale. Therefore, A to G sharp would be a major seventh. But I wrote A to G natural. That's a minor seventh. But you can see how spelling out this scale takes a much longer time. And if I can relate this larger interval to its inverted counterpart, I can very quickly get the right answer. Here's the takeaway. Seconds always invert to sevenths and vice versa. And major intervals always invert to minor ones and vice versa. Cool. This also can work for thirds and sixths. Take a look at these examples. How would we label this interval? Well, it goes line to line, and we can count E, F, G, so we know it's a third. The question is, would it be a major third or a minor third? It is a minor third. Why? Because if it were a major third, it would have to be G sharp, because G sharp would be scale degree 3 in the key of E major. But we have G natural instead, so it's a half step smaller, therefore it's the minor version. If I want to use interval inversion, let me show you how that would look. We take the lower note, displace it by an octave above, and the third is now going to invert to a sixth. And recall from just a few moments ago, we know that minor intervals always invert to major ones. Therefore, the quality from G to E is going to be a major sixth. I'll prove it to you. There's our sixth. E is the sixth scale degree in the G major scale. Therefore, G to E is a major sixth. Let's try another one. C to E is a major third. How do we know that? Well, the lower note is C. Therefore, we can think in the key of C major. Lucky for us, that's no sharps, no flats. And E, therefore, would be in the C major scale. So that's how we know it is a major third. When I invert it, That will invert to a minor sixth because major intervals invert to minor ones and thirds invert to sixths. And because I like to prove it to you, let's relate it to the E major scale. If we were to have a major sixth with E as the lower note, it would have to go to C sharp because C sharp is scale degree 6 in the key of E major. However, my original interval is E to C natural, a half step smaller, and that's why it's minor. Here are our takeaways. We can take any major interval and invert it to become minor or vice versa. Seconds invert to sevenths and vice versa. And thirds invert to sixths and sixths invert to thirds. You might want to remember the magic number 9. Because when you use interval inversion, both intervals add up to 9 always. And you can use interval inversion as a quick tool either to check your work when deriving intervals from major scales, or you can use it as a shorthand that you can just rely on to do interval identification and construction quite quickly.